Hello everyone, welcome to Dr. Ravi's Academy. In today's lecture, you will be understanding how to draw SFD, that is shear force diagram, as well as BMD, bending moment diagram, for a overhanging beam. Let us look at the diagram. He has given a length of the beam is 5 meters and up to 2 meters it is subjected to UDL of 20 kilonewton per meter length, and at the end of 2 meters you have 40 kilonewtons, and beyond the support B it is subjected to 20 kilonewtons. So this is the given beam. As you know, you can solve this problem by means of 3 steps. The very first step is you can write down, that is step number 1 is support reactions. You have to find out support reactions at A and B. Support reactions at A and B by considering the equilibrium of the beam. And let us write down the sum of the moments about point A, that is left end, is equals to 0, and treat anti-clockwise moments are positive. With this notation, write the moment equation, and your moment equation is 20 kilonewtons into 2, so that is 40 into moment arm is 2 by 1, that is 2 by 2 is 1, it becomes 1. So the load is 20 into 2, 40 kilonewtons acting at the midpoint, that is at 1 meter. So this is clockwise and notation is minus. And you have a point load of 40 kilonewtons, which is at a distance of 2 meters, and the other end you have 20 kilonewtons, 20 into the moment arm is 2 plus 2 plus 1, that is 5. So these are the 3 loads contributing clockwise turning effect and negative, and support reaction is it is plus contributing anti-clockwise, or B into moment arm is 2 plus 2 4 is equals to 0. This is your moment equation. Write down RB, calculate RB. For RB is equals to, if you take the other side, 40 into 1, that is 40, plus 40 into 2, 80, plus 20 into 500. So the total becomes it's 100 plus 180 plus it is 220. 220 divided by 4 is your RB. So this value is 55 kilonewtons. Your RB is 55 kilonewtons. That's support reaction. And writing the force equation sigma Fy is equals to 0, you can find out the other support reaction, that is RA. Your downward, it is RA and RB. RA plus RB is equals to, your downward force is 20 into 2, that is 40. So 40 is UDL load, and 40 again 40 is the point load, again plus 20. So this becomes 100, and your RA is equals to this minus RB. RB you got it as 55, so it is 45 kilonewtons. So this is very first type of a problem with overhanging beam as well as simply supported beam. You got RA as 45 kilonewtons. After determining this, your second step is step number 2 is your SFD, equations for SFD. So let us write down the equations, and before writing the equations, let us select the sections. I am selecting first section within the UDL, that I am calling it as my x1 distance. This is x1, and let me call from the right it is x2, and the third section is x3. So 3 sections, this is your 3 and 3, distance is x3, this is the 2 and 2, distance is x2, and this is 1 and 1, distance is x1. So with these 3 section lines, let us write shear force equations as well as bending moment equations. Now your Vx1, V is the standard notation for the shear force. I am writing Vx1 is equals to, so this is my section, and 45 kilonewtons is contributing clockwise turning effect. Clockwise turning effect is positive, so your shear force is plus 45, whereas UDL is contributing anti-clockwise turning effect and it is minus, so minus 20, the distance is x1, into x1. So this is what exactly the shear force equation, and at x1 is equals to 0, that means it is 0, your shear force is 45. So Vx1 is 45, and at x is equals to x1 is equals to, let us say, it is at the end of it, that is 2 meters. So your Vx1 becomes, it is 45 minus, it is 20 into 2, that is 40, and the value is 5. So at these two salient points, you got it is 45 and 5. Now let us write down the shear force equation Vx2. Vx2 is equals to your section 2, that is this is the section, and 20 kilonewtons is contributing clockwise turning effect, and 20 is positive. So this value is positive, and this is valid. X2 is equals to 0 to, now x2 is equals to 0, this is 0 to your 1 meter. X2 is equals to, this is valid throughout this, and the last equation, that is Vx3 is equals to, it is 20 kilonewtons contributing clockwise turning effect, that is positive, minus 55 kilonewtons, this is contributing anti-clockwise, it is minus 55, and this value is minus 35. Now you got all the values of the shear force required for shear force diagram. That is your step 2. And step 3 is bending moment diagram, for bending moment diagram. It is BMD. So let us consider the same sections and write down the equations. Now your equation is, the notation is mx1 is equals to, write down here mx1 is equals to, your equation is, as you know, your what's up symbol, smile effect contributes clockwise bending. It is positive bending. Now about this particular section, your 55 kilonewtons, here 45 kilonewtons contributes smile effect, and it is positive. So your 45 is positive, and whereas the moment contributed by 20 kilonewtons, it is sad effect, and it's minus 20 into x1 is the force, and the moment is x1 by 2. So here 45 into, so we did not write this x1, here it is x1. So your value is 45 x1 minus 10 x1 square. This is the equation, and you can find out the values at x1 is equals to 0. Here this value is 0, mx1 is 0, and at x1 is equals to, let us take 2 meters, it is 2, that means here it is, here the value is mx1 is, let us look at the equation, 45 into 2, that is 90, minus x is 2 square, it is 4, 4 into 10, that is 40, and it becomes 50. The value is 50. Now let us write down mx2 equation. Mx2 is this equation, and 20 kilonewtons contributes a sad effect, that is minus 20 into x2, and at x2 is equals to 0, your mx2 is 0, and at x2 is equals to, the value, limiting value is 1. If it is 1, so your mx2 becomes, it is minus 20. So this value goes up to minus 20. And lastly, the third section, that is mx3. Write down mx3 is equals to, so this is the equation. Your 20 kilonewtons contribute side effect, it's minus 20 into x3, and 55 kilonewtons contribute smile effect, that is positive 55 into, it is what the distance? It is x3 minus 1. x3 minus 1. So at x3 is equals to 1, this becomes 0, it is minus 20, your mx3 is minus 20, and at x3 is equals to, it is 3 meters, your mx3 becomes, it is 3 is minus 20 into 3, that is minus 60, and 3 minus 1 2 into 55, that is 110 plus 110. This value is 50. You got all the salient values at salient points, the values of SFD as well as BMD. Now you can just proceed to draw. Let us draw the alignment lines. According to this, you will be drawing the SFD and BMD. Now draw the neutral axis. Here you can just keep these values aside. So it is x at x is equals to 0. At x1 is equals to 0, it is Vx1 is 45, and at x1 is equals to 2, so your Vx1 becomes 5. I am just erasing this. I would like to draw the SFD and BMD aligned with the configuration diagram. So let us draw the neutral axis line NA, and let us mark salient points of shear force diagram. Here SFD at x1 is equals to 0, it is 45, the value is 45, it is plus 45. Let us look at this is 45, and at x is equals to 2, this point, this value is 5. So join these two by means of a straight line, and let us proceed to x2. When x2 is equals to 0, mx it is x2 is equals to 0, 0 to 1, it is constant, plus 20, it is plus 20. So here this remains constant, that is 20 plus 20. And Vx3, it is x2 is equal to 0, it is Vx3 is 55 minus 35. So it goes up to minus 35, somewhere here you have 35, which is constant, minus 35. And this what is your required, this is plus, right? This what is your required SFD. This is your SFD. Now let us proceed to draw the bending moment diagram. Neutral axis of the bending moment diagram, that is NA. Now let us mark salient points on this. When it is mx1, when x1 is equals to 0, here this is 0, and when it is 2, your value is it goes up to 2, it is minus 20. X1 is equal to 0, mx1 is this is 50. This goes up to 50. This value is 50, and you see that that equation is the equation is parabolic. You can draw, it's parabolic. You can draw a parabola, and for x2 it is x2 is equals to 0, you have 0, x2 is equals to 1, you have minus 20. So this is 0, and you have minus 20. And for x3, it is minus 22 goes up to 50. You can simply join by means of a straight line, 50. And this is positive, here this is negative. This is a straight line equation, 0 to this. So let us give a hatching, and this is your BMD. Thank you.